Alright, yesterday we used the properties of logarithms to expand and contract equations. Three properties were log of a, log base a, of m times n, which is an addition problem. Log base a of m divided by n, which is a subtraction problem. And log of base a of m to the power of n, which is written as a, you bring the exponent to a coefficient. We're going to use those three today to solve problems. So let's start simple. I have log base 4 of x equals 2. We've seen a bunch of these at this point. I just take 4 on both sides to cross them out, and I have x equals to 16. Same problem with a leading coefficient of 2. Well, I can't say 4 to the power of all of this because that leading coefficient right there. I can only do that when I have a log by itself. So we're going to use the property we talked about yesterday where we said that log base a of m to the power of n can be written this way. Alright, so just like we can bring the exponent down, we can put them back on top today. So this 2 can come up on top, give me log base 4 of x squared equals to 2. Well, now I can do the same process I did up here. Both sides to the base of 4. That crosses out, x squared equals to 16. To finish, I square root both sides, so x equals to plus or minus the square root of 16, which is plus or minus 4. And to refresh your memory, you cannot take a log of negative numbers, so our final answer is x equals to 4. So we're using this property to solve, to figure out what x would be. Continuing, what if we had a problem like this? Log of x plus log of x plus 21 equals to 2. Now remember, log with nothing under it is really log base 10. Alright? I can't say 10 to the power of log plus log. I have to get down to one log step before I can do that. But what I can do is use the fact it's an addition problem and rewrite it this way. That's really log base 10 of, remember yesterday, multiplication problems can be written as addition problems. So we had log base a of m times n yesterday can be written this way. Log base a of m plus log base a of n. Well, same thing here. We have a plus sign, so we write it as a multiplication problem. That is x times x plus 21 equals to 2. Now I have a singular log statement. I can take 10 to the power of on both sides to cross that out. And I'll have x times x plus 21 equals to 100. To solve this, I need a factor. So distribute x squared plus 21x minus 100 equals 0. That would be x plus 25, x minus 4 equals 0. So x equals to negative 25, and x equals to 4. You can't have negatives, so x equals to 4 would be your answer. Okay. One last example for you. What if I had the natural log of x plus 1 minus the natural log of x equals to 2? Okay, so this is a subtraction problem. Remember from yesterday, log base a of m divided by n equals to log base a of m minus log base a of n. Well, I have a minus problem. Let's write it as a division problem. That is natural log of x plus 1 over x equals to 2. I have a single log statement. I can undo the natural log with the e. So that is x plus 1 equals to e squared. So x plus 1 over x equals to e squared. To solve that, I multiply up. X plus 1 equals to x times e squared. get my e statements together. So 1 equals to x times e squared minus x. Undistributed x, I have 1 equals to x times e squared minus 1. Don't forget, we divide both by x. There's a 1 left over right here. Finally, divide to solve for x. 1 divided by e squared minus